everyone, welcome to today's Explainer. I am absolutely thrilled to have you joining us. You know, stepping into an 8th grade science lab is hands down one of the most exciting parts of middle school. But here's the secret. A science lab isn't just a playroom. It's a space designed for real, powerful reactions. We're talking about real materials, real heat, and real chemicals here. Because of that, the way we conduct ourselves in this space matters immensely. Today, we're going to look at how following lab protocols isn't just about keeping the teacher happy, it's actually a profound measure of our personal responsibility and character.
Okay, here is our quick roadmap for today. We'll cover the foundation of safety, run through personal and chemical protocols, and talk about handling equipment. After that, we'll test your knowledge with some real-life lab scenarios, do a quick knowledge check, and tie the whole shebang back to education and biblical morality.
All right, let's jump right into Section 1, the foundation of safety.
I want you to think about this one short, super powerful command from Proverbs 20, verse 7, walk in integrity. Now, you might be wondering, what on earth does integrity have to do with science? Well, literally everything. Bringing integrity into the lab means making responsible choices, even when it's kind of inconvenient. It means choosing to protect your classmates, honoring the equipment we're so incredibly blessed to use, and being entirely honest with the data we collect. When you strap your safety goggles on, you aren't just checking off a rule. You are quite literally walking in integrity.
Let's break down what safety really means here. It is the absolute foundation of every single investigation we do. It's an act of integrity that protects 3 crucial things: people, equipment, and results. As 8th graders, you're handling real, potent lab materials. Being careless doesn't just mean a broken beaker, it can lead to real physical injuries. Plus, if we aren't safe and precise, we completely wreck the honest data we are trying so hard to collect. Safety is the shield that keeps our investigations both productive and truthful.
Moving right along to Section 2, personal and chemical safety. Okay, these personal safety rules, they are non-negotiable. First up, wear your goggles. Gotta protect those eyes. You also need closed-toe shoes to protect your feet from dropped objects or gross spills. Make sure to secure any loose hair or baggy clothes. I mean, unless you want an unexpected and very permanent new haircut from a Bunsen burner, which, trust me, you don't. Never, ever eat or drink in the lab because chemical residue transfers to your food way too easily. And always follow your teacher's instructions before you touch a single thing. Tying your hair back or lacing up those shoes is a direct act of taking responsibility for your own physical well-being. Next up are chemical safety protocols. Rule number 1, read those labels carefully. Never just assume you know what a clear liquid is. And definitely never mix unknown chemicals just to see what happens. That's exactly how dangerous, unexpected reactions pop off. Always use the proper tools. We're talking droppers, tongs, gloves to handle your materials. Oh, and this is absolutely crucial. You need to know exactly where the eye wash station, the fire extinguisher, and the exits are before an emergency actually happens. By checking labels and knowing your surroundings, you're actively creating an awesome culture of preparedness where everyone in the room can just focus on learning safely.
All right, into Section 3 we go, handling equipment safely.
Before you even begin, give your tools a quick inspection. Are there cracks in your glassware? Frayed cords on the hot plate? Spot those early. If you're using heat, always grab a heat-resistant pad to protect the tables. Now here's a massive one. Never, under any circumstances, point an open test tube at yourself or anyone else while it's reacting or being heated. Pointing a loaded test tube at a classmate shows a complete lack of empathy and respect for their safety. And finally, when the experiment is all wrapped up, dispose of your materials exactly how you're directed. Don't just dump the whole thing down the sink. And wash your hands. Always wash your hands.
Okay, Section 4. Let's look at some real lab scenarios.
Picture this situation. You are standing at your station doing a simple, seemingly harmless vinegar and baking soda reaction. It's bubbling and fizzing away, and then suddenly, pop, a droplet splashes right up. So, what happens next?
Well, it all depends on the choices you made beforehand. The student who actually chose to wear their goggles simply wipes the splash away, laughs it off, and keeps right on going with the experiment safely. But the student who thought the goggles were annoying and just left them sitting up on their forehead, they now have an acidic chemical right in their eye and have to sprint to the eye wash station. See, wearing goggles is just a super simple, easy choice that keeps your investigation moving and keeps you pain-free. Scenario number 2. Let's say your experiment requires boiling water, and it's time to take a glass beaker off a hot plate. How exactly do you handle that? Keep in mind, heat in a science lab can be completely invisible. A piece of glass looks the exact same whether it's sitting at room temperature or cranked up to 200 degrees. The right move here? Use tongs or heat-resistant gloves and carefully set that beaker onto a heat-safe pad. The incredibly painful lesson you'll learn if you don't: severe thermal burns. Ouch. Assuming a piece of glass is cool just because it isn't glowing cherry red is a really careless, dangerous mistake. Using the proper tools demonstrates a healthy respect for the potent forces we're working with in the lab.
All right, final scenario. The bell is about to ring, you are rushing to finish up your lab, and you desperately need water. You reach for a beaker of quote-unquote clear liquid sitting in an unmarked container that the last class just left behind. What do? I mean, it is incredibly tempting to just pour it in and hope for the best so you can get out of there, right? But here is where your integrity truly gets put to the test. The good practice is to never, ever use unlabeled substances. You stop and you ask your teacher. The hard lesson you'll learn if you just use it anyway? First off, it's wildly dangerous. That could actually be hydrochloric acid, not water. Second, it completely invalidates your whole experiment. Guessing what a chemical might be is basically the exact opposite of scientific integrity. It totally ruins honest data collection. Simple rule: if you don't know what it is, you don't use it. Period.
Moving on to Section 5, a quick knowledge check.
For your homework tonight, you'll need to do a few things. First, list 4 personal safety rules and explain exactly why they matter. Then, describe how you'd handle a minor spill, map out 3 of our emergency equipment locations, and write down a 5-step station prep checklist. But here is the really crucial part. You also need to explain how doing a poor job at cleanup actually hurts the students coming in for tomorrow's class. Leaving a mess is just plain selfish, guys. Cleaning it up? That is an act of service.
And finally, Section 6, Education and Biblical Morality. Romans chapter 8, verses 6 and 7 promises peace of mind to everyone who keeps his or her mind spiritual. Think about how that applies to a busy, sometimes chaotic science lab. When you bring a spiritual, responsible, and caring mindset into that space, when you are truly walking in integrity, you bring peace and safety right along with you. You're not sitting there anxious about causing an accident because you know you are meticulously following the very protocols designed to protect you. Which really brings us to the core philosophy of the Hero Smart Academy Godly Learner series. Education without morality will hurt. Let me just say that one more time. Education without morality will hurt. Being book smart or knowing exactly how to balance a complex chemical equation, that means absolutely nothing if we don't have the moral compass to use that knowledge responsibly, to protect the people around us, and to honestly report what we find. So, I want to leave you guys with a couple of big questions to chew on. What is the point of being educated if we just continue to make careless choices that hurt ourselves or our classmates? And more importantly, how are you going to consciously choose to walk in integrity during your very next lab investigation? Always remember, every single time you snap on those safety goggles, you're making a moral choice to protect the amazing gifts you've been given. Thanks so much for hanging out with me for this explainer. Keep those minds sharp, keep your character strong, and I will see you in the lab.